So now we want a Lewis structure of PBr5. Okay, so for this, we definitely first need to know how many electrons we're working with. So we're going to go to our handy periodic table, okay? So phosphorus is right here on the 15th column. So you could say that it has 5 electrons. You could also figure this out by doing the electron configuration. So if I just did the shorthand right now, okay, we'd start with neon. And it'll be 2s2 2p3. Okay, and that shows right there in this valence electron in its outer shell, it has 5 electrons. Now with the Br, similar thing here, but it's actually just going to be one row down, and it's going to be on the 17th column. Okay, so with that being said though, because it's on the 17th column, I will still say mostly likely has 7 valence electrons, and we can actually see this when we do this. So we have, it'd be argon, because that's where we start for bromine. Okay, and then we're gonna do 2s2. Whoops, sorry, already passed that row. And this will be 2. That actually be 3. 3s2, 3p3. It's on the 3rd row, and this will be 4s2, 3d10, because it's passing through the transition metals, and then the 4p5. And because the 3d10 is done in the 3rd shell, we only count these 2, so 2 plus 5, that's definitely 7. So now we know that phosphorus has 5 valence electrons and bromine has 7. Okay, so now we need to figure out the actual Lewis structure. Let's see how many electrons we're working with. We have 5, okay, plus 7 times 5. So that's 35 plus 5, that's 40 electrons total that we're working with, okay? So with that being said, let's start drawing it out. Now phosphorus is the only individual one, so I'm going to start there. I'm going to just take a quick guess here actually, because phosphorus has 5 valence electrons, so I'm pretty sure that the bromine would just be surrounding it. But let me just draw it as if it was 4 first. Okay. So now, with that being said, let's add the bromines. So we're going to add the 4 first. Okay. But it actually says 5 though. Okay. So now here's where I add the extra one. Give it a little bit of room there. Alright. So now we have all the bromines. And now let us go ahead and add the electrode. So phosphorus is actually sharing 5 of its 5 already, so we don't need to add any there. The bromines, on the other hand, are sharing 1 of its 7. So 2, 3, 4, 5, 6, 7. 2, 3, whoops. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. Okay, and now we can't forget that extra bromine. 2, 3, 4, 5, 6, 7. So if we just quickly count this out, hopefully we'll have 40 electrons. We have 8 times 8 times 8. Whoops, 8 plus 8 plus 8 plus 8, and then plus another 8. That is indeed 40 electrons. So that is perfect. So now technically we have the Lewis structure for this. The way to really, well, not verify, but just support more of our answer is just to make sure that we do the let's see, the no, so it's an N. No, sorry, formal charge. Let's start with N. Formal charge. Okay. So with that being said, okay, we have phosphorus likes to have 5 valence electrons. Okay. And it's right now sharing, well, it has 0 by itself, but it's sharing 10 of them. Okay, so that's a plus. And with that being said, that's going to be 0 because it's going to be 5 minus 5. And then on the bromines, okay, we have 7 valence electrons, but it has now 6 electrons by itself. That'll be 2 over 2. So that's 7 minus 7. That also equals 0. Okay. So that being said, we got our formal charges. We're all good to go. So theoretically, this right here should be the Lewis structure for PBr5. Let's see how we did. So exactly, circled it with bromines. They added one bond, and then they added the electrons. Okay, so this is correct. Okay, so with that being said, let's move on to the next question. Question 4.